Hi all, here begins our third video in our BNB Chain tutorial series. Starting from this video, we will be discussing the programming language that we use when we are trying to develop a smart contract called the Solidity language. Because it's a bit long, we divide it into several parts. In this first part, we will be giving an introduction to the Solidity language, and then we will talk about variables, types, and control structures in this language. First, an introduction. Solidity is an object-oriented, high-level programming language for implementing smart contracts. It is a curly bracket language designed to target the EVM. It is influenced by C++, Python, and JavaScript. Solidity is statically typed, supports inheritance libraries, and complex user-defined types, among other features. All these features, we will see how to use and implement them. The basic component in Solidity language, like class in other object-oriented programming language, like C++, is called contract. And a contract declaration in Solidity should provide the expected information about a contract running on the blockchain. So they should map or correspond to each other. After programming, the Solidity language contract can be compiled and deployed to the BNB chain. And then it will run as a smart contract on the network. Before talking into syntax about Solidity, we will talk about several predefined variables, which follows the last video about the architecture in EVM. That these will provide related information for processing calls and requests to the smart contracts. The first one is called message, written MSG. Message stores the information about message calls. Just a quick review, message calls act quite like transactions in the way that it has a sender, it has a receiver, it has data with it, and it can also send native assets like Ether or BNB together with it. It is often used to invoke a function or create a contract or anything. Message.data is in type bytes, so it's an array of byte that will store the call data of this message call. This will often be used to pass needed information, probably serve as input parameters for the functions that are invoked. Message.guess is in type unsigned int, providing the remaining guess of this message call. It is not recommended in later versions of Solidity, and the recommended substitution is called guessLeft. It is not like message.guessLeft, it's just a function, guessLeft. Message.sender is an address that is the sender of the current message call. This is extremely useful when implementing smart contracts. Let me give you two examples. One is, say you want to implement a token, and you said that like anybody can transfer some Ether to me in order to buy my token. To implement that, you have a mapping, you have a balance storage to store the remaining token of each account. And when somebody was trying to buy some token from you, they send money to this contract. Then the contract should add the corresponding token number to the balance of message.sender. So message.sender allows you to recognize who is sending this information. Another example, say some function, some activity is restricted to be only invoked by the owner or the creator of the contract. For example, like self-destruct. You get a function for self-destruct. And you say this can only be invoked by the creator of the contract. So what you do is, whenever you receive a message call trying to destruct this contract, you check that message.sender is the same as the owner or creator stored inside the storage of this contract. This way, it serves as a verifier to restrict the caller to only a selected group of user. Next, message.sig is of type bytes4, so it's 4 bytes. The first 4 byte of call data, which basically stores the function identifier. And finally, message.value is the number of assets sent together with the message. So this is like how many ether, how many BNB is sent with this message. Next variable we need to talk about is called block. It gives the information about the current block. I think it is used less frequently than message, but we still need to know about it. Block.chain ID, Coinbase difficulty, gas limit, number, and timestamp all gives the corresponding information. The name should be rather self-explanatory. Just one thing to notice about Coinbase. It gives the current block miner's address, and it's of type address payable. We will see address in just next slide, but quick explanation here is that address stores 160-bit word, which is the address of an account, as we discussed in the last video. And payable is a suffix here marking that you can send ether or any assets to this address. Block hash with block number passing in as a parameter will give the hash of the given block. So I mean, this is not necessarily a variable, but it also gives information of block, so I just put it here as well. These are the related information that we probably need inside smart contracts and can be accessed through this variable called block. Then we start talking about the types available in Solidity. Aside from like normal types, int, boolean, all this, a special type is available in Solidity called address because it targets the EVM and should serve as the programming language to develop smart contracts. Address stores 106 bit of an address, and there are 2 ways of declaring an address and address payable. Their only difference is that you can send assets to address payable. Given an address X, or like address payable X, address.balance or x.balance will give the balance of this address, and x.send and x.transfer will send money to the address from the current account or contract. Note that x.send is not sending ether from X, but rather sending ether to X from the current account. So like, because here in Solidity language, you implement stuff inside a contract, and executing this line will transfer from the current contract to the target account. We see an example of this. Address payable X equals address, say like 123, anything. Address payable Y is address this. This is the current contract. If x.balance is smaller than 10 and y.balance is greater than 10, x.transfer 10. This means that if we have enough money, we have more than 10 balance, we will transfer to X 10 ether. The other types are just quite easy to understand because they are very similar to types in other languages. Boolean, it is used to declare like Boolean variables. We use bool to declare like say bool x or something. The operations are negation, and, or, equals, and not equals. The and or are short circuit operations. That means x and y. If x is evaluated to false, then y is not evaluated and not invoked. Types int, integer. Is declared using int x or uint x, where x is a multiple of 8 between 8 and 256, standing for the number of bits. Say like int 32v stands for declaring a variable called v of 32-bit signed integer. Uint 32v just defines the same thing, but now it's unsigned. Operations is similar to other languages. There are comparisons of smaller than or equal to, smaller, equal to, not equal to, all this. It also has bitwise operation, and, or, exclusive, or, bitwise negate, left shift, right shift. The arithmetic is like plus, minus, unary negation, multiplication, division, modulo, and power. Type x.min and type x.max will give the upper bound and lower bound of a type. So like type int32.min will probably give you like negative 200 million something. Integer overflow will just cut at the expected bits. So like it will say still int32, it will just keep the last 32 bits of the result and cut anything that's further extending. Next type is array. Normal array just declare easily, like int a10 declare an array called a. The elements are of type int and it is of length 10. You can have variable length array, which is declared using int a without a length. This is an array with mutable length, does not have a fixed length at the beginning. You can use a.length to return the current length of a, and use a.push to extend a new element and return the new length. So this acts pretty much like list or vector in C, or list in other languages. There are also fixed length array that are not declared with length at the end but at the beginning. So these can be understood as some special types or predefined types called bytes 1, bytes 2, etc. until like bytes 32. Bytes x, a means an array storing x bytes, and you can use AI to access ith bytes. The next type about char and string. For char, declare use char for a character variable. String will act like a char array, but currently you can't use dot length and index access. Instead, you have to use bytes to change to byted data. An example is shown below, string s, and you need to do like bytes s dot length in order to get the length of this s. And bytes s7 equals x instead of s7 equals x. So this is how you should access string or char array right now in current version of Solidity. They might update it in the future, but for now we have to live with this. Another type is called mapping. Mapping implements a hash table. To declare mapping, use mapping key type to value type. And arrow is just equals greater than. So it looks pretty much like an arrow, and you just write this. It is commonly used for like example. For example, you storing account related information. You can use mapping. The example given below is contract balance and mapping address, mapping to unsigned int public balances. This public signature is the visibility, which we will be talking about in the next video. And then we have a function update unsigned int new balance public, and we say balance message.sender equals new balance. This is the syntax for mapping. I understand the syntax for function hasn't been covered, but this function should be rather easy to understand, and we will discuss about function in the next video. Here is the example that message.sender is important because here you only want to update the balance of the person or the account who invoked this function, not everybody. So you need to know who did that, and message.sender will give you this information. Solidity also allow user-defined structs and user-defined types. Declare structs to store packed data. Simple example below should be rather self-explanatory. We have struct voter with 4 related information with it, and then we can declare like voter v to declare all this information at the same time. Another type in Solidity is called enum. It is a declaration of types, and to declare type that has a fixed number of constants, so it can only select from the value that you give. Here the example below is like contract purchase and enum state, ranging from created, locked, and inactive, mapping address to state, public states, and then now like state, say address 123 will give a state, and it's either created, locked, or inactive. So that's declaring user-defined type with fixed number of constant value they can range. Then the type we need to talk about is called event. Use event to trigger the logs in EVM. As discussed in the last video, logs in EVM are something that can map directly to the block level and can be seen and accessed from the outer world of blockchain. To declare and use event, use the following sentence. Event acts with parameter types will declare an event that will further be emitted by other functions. And then whenever you want to emit a function, you call emit. And when you want to emit an event, you call emit. An example here is in a contract called coin. Then the event is called send. Inside this event, we need to memorize sender, receiver, and amount. Then suppose you have a function sent, and it's called like public payable. These two are signatures. Public is for stating that this can be called from other contracts, and payable means others can send ether to it. Other than that, this should be self-explanatory. And function sent public payable, you execute this, and after everything is done, you emit a send event with message.sender as sender, message.receiver as receiver, and message.value as amount. So now outside the blockchain, you can see a log in this blockchain. There's an event called send emitted, so you know what is going on inside the log. Finally, we enter the part of control structures. The control structures aren't that hard. It is similar to most other languages. Has if, else, while, do, for, break, continue, return, and question mark, colon. So it's a conditional operator. Notice that Solidity have no go-to statement. This is easy to understand because blockchain should make sure it is safe and it is not messy, and go-to is very easy to make stuff messy. Also notice that there are no auto type conversion for a control structure in Solidity. So you cannot write something like if 1 blah 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 or if x blah blah blah, unless x is a boolean, but otherwise this will lead to a compile error. Solidity also supports exception handling in the form of track catch statement, but only for external function calls and contract creation calls. Errors can be created using the revert statement. Errors and reverts in Solidity. Arrows provide a convenient and gas-efficient way to explain to the user why an operation failed. They can be defined inside and outside of contracts. like including interfaces and libraries. They have to be used together with revert statement, which causes all changes in the current call to be reverted and passes the error data back to the caller. As we said, the EVM model is atomic, so you can't execute a part of a function. You either execute all of it or none of it. When revert happens, it will call the EVM to revert all changes made to the state. The reason for reverting is that there is no safe way to continue execution because unexpected effect did not occur. So to make sure safety, you just stops anything and revert all the effects. The reverse statement can be of form require or assert. So the statement require condition description would be equivalent to if not condition revert error description if you could define error string. However, like error is a built-in type and cannot be defined in user supplied code. So like you can't really do that. But if you want to do that, you need to use require. One example for require is like require message of value is not 0, otherwise say you don't pay enough money, something like this. So if that happens, it will revert all the sentence before and return an error saying you don't have enough money. Similarly, you can call statement assert. Assert has the same syntax as require, like assert condition description. It will revert with an error of the built-in type called panic unsigned int 256. So they act similar, but just the exception that you should catch is different. That is pretty much all for today. The first part of Solidity language, we talked about predefined variables, message and block that will provide related information for you. Then we discussed the types and control structures in Solidity language. In the next video, we will start talking about functions, the signatures we've seen just now, visibility, and then the structure of a contract. So then we can understand how is a contract created and programmed. See you in the next video.